So in this last two examples, you will encounter more difficult question where it might involve two different maps. So a same location can be represented by two maps. So for example, your school can be represented on this map and another map. But sometimes you may be thinking like, why my school looks smaller on this map and why my school look bigger on the other map? So it might look different on maps because of the scale. So we always is restricted by the scale, and it will look different on different map. But the critical thing is, right, the actual distance doesn't change or the actual area doesn't change. So if you encounter question with two maps, you must always remember uh, the map area can change, the map length can change, but then the actual distance or actual area doesn't change. So in order to link two maps, you always use the actual distance or actual area to link the two different maps. So that's one of the things. So we can look at it through this two example. So if you look at this example, the scale of map A. So if there are two maps, please be mindful. You better indicate which map are you interpreting. So 1 centimeter represent 400 centimeter actual distance. So this 400 can be 4 meter or it can be 0.004 kilometer. Okay, so have an awareness, which one are you interpreting first? Okay, so there's a rectangular plot of length. So this rectangular plot looks at 6 centimeter and 2.5 centimeter. So I like to find the actual parameter. So part A, we are finding the actual parameter. So of course, there are two methods that you can do. So this is the map length. Can you go and find the actual length? So this is the map breadth. Can you find the actual breadth? So you might want to find them separately and then you add up the actual length. Okay, but the easier way will be, of course, I just find the map parameter first. Okay, to me, it will be so much easier if I find the map parameter. That means, right, I want to find out the parameter of the rectangle on the map. So it will be 6 plus 6 plus 2.5 plus 2.5. So that is 17 centimeter. So if I have the parameter on the map, so 17 centimeter will represent 17 times 4 meter. So the actual parameter is 68 meters. So if you are the kind who is not mindful of units, you don't label, you'll find very, very confusing. So if you look at my working, right, my working always label. So again, in case you forgot what is label, label means you just write the words to represent your working. That means you label your working. What does your working tell? What are you showing? Okay, so that is like explained with just a couple of words. Okay, then the next one, I would like to find the actual area. So if I would like to find the actual area, of course, I need the area scale. So I will need the actual area in meter square. So I'll be squaring these two. So I'll be squaring these two. So I'll square according to the units. I'm not going to square centimeter. It's not going to help. Okay, so bear in mind, you square according to what units you like based on the question. So if you do this part right, this is the one that you will be awarded method marks. If you forgot this statement or this statement is not present, sometimes you don't get your method marks or answer mark at all. So from here, I need to find the actual area, but do I even have the map area? So of course, I'm going to find my mapped area. That will be 6 centimeter times 2.5 centimeter. So from here, I know 15 centimeter square will represent 15 times 16 meters square. So the actual area, so again, write a statement. So now the critical part, we suddenly is going to have another new map. So the next part, take note, we got a brand new map. So now this is map B. So we already got but we are interested. So this map B, right, with this new map, how does the plot of land look like? Will it get smaller or will it get bigger on this? Okay, so don't forget, the map area can change. The actual area couldn't change. So later on, I'm going to make use of the actual area. I need to make use of the actual areas so that I can convert to the next map. So let's explore the scale first. Okay, 1 centimeter represent 5 meter actual distance. So of course, you got to get to your area. So that means, right, how will the 240 look like on the actual area? So how will the 240 meter square look like on this map? So you should be asking how many 25 meter square are there in 240 meter square? So 240 meter square divided by 25 meter square, you will get 9.6. So just now, right, it was actually 15 centimeter square. So now the same area, when I put it on the other map, it actually looks smaller. So the land is, so right now, this piece of land is 9.6 centimeter square on map B. So just now it was 15 centimeter square on map A. So the map area can change because that depends on the scale, but the actual area doesn't change. So this is something that you got to take note. Okay. That's why you need to go through the, it's good that you label your working so that you know where are you heading. So in the next example, okay, the next example is the kind of example, they don't start you with a length scale. They actually start you with a area scale. So if you look at the question, they gave you something about the area. and they actually wanted a length. So how are you going to change it up? So you actually got to do the square roots that I mentioned just now in example 4. So you actually got to do a square root. So this is the one that's confusing. So you are not starting with length, you are starting with area. So you're going to work backwards. So the work backwards includes squaring, taking square roots. And there's also a technique about taking square root. Okay, so let's interpret the questions first. So 2.5 centimeter square represent 22.5 kilometer square actual area. We are not going to be taking square root here. I will only be taking square root when I get to a 1 centimeter square. So you divide by 2.5 on both sides. So I'll always get to 1 centimeter square. Then I will take a square root. To get the actual distance. Because if you square root 1, it's a 1. If you square root a 9, it's a 3. So now I got the distance. And if I need the scale, I hope you still remember, it has to be in centimeter. So you convert slowly to the centimeter. To make things easier, you just convert here. Convert to meter, convert to centimeter. And once you hit the centimeter, you will get the scale. Drop the centimeter. So this is the working backwards part. The rest will be the same. So the rest will be the same procedure that you have encountered. So for example, in part B, road is 5 kilometer and 40 meter. So in this case, please convert. Please convert to kilometer first. So this is the actual distance. I like to find the map distance. So you gotta think about this part. So every 1 centimeter is 3 kilometer. So every 3 kilometer will reduce to 1 centimeter. So how many 3 kilometer are there? So you got to reduce, go and calculate how many groups of 3 kilometer. So you get 1.68 group. So the road is 1.68 centimeter on the map. It's very short, 1.68 centimeter, but it actually ends up like 5 kilometer plus. And then subsequently, the last part, we have comparing about area. So if you're comparing about area, I will be doing this. I'll be using a nice number. I no need to repeat, I just take the nice number. So remember, 1 centimeter square on the map represent 9 kilometer square actual area. So now I got the actual area. So how many 9 kilometer square are there in the actual area? So take the actual area divided by how many groups of 9 kilometer. So the lake is just a tiny 2.8 centimeter. Okay, so you be mindful of what you have. So that's why maybe writing words will help you and then you look back, and of course writing units. If you always forget to write units, you will find this whole topic very confusing, because there will be quite a lot of interchanging around in the units. So this one is a very short topic. Okay, comparing length ratio, comparing area ratio.